doing. All right, class, we're going to look at fundamental theorem of calculus. And I already covered it the other day, a little bit. We'll call it first fundamental theorem of calculus. All right, this we already went over this. F of x equal dx for f of b minus f of a, where f is the antiderivative of f. All right, now so if we do a problem something like this, -1, -2 to -1 of u1 minus u squared du, what would be the we call this definite integral. So it's pretty simple. Let's do the antiderivative for those. We get u squared over 2 plus u to the -1 over 1. From -2 to -1. We could simplify it, or if we just plug it in, and you will eventually get -1/2 minus 3, which is -2. And check this out. You got the answer to be negative. Why is that? If you take this function and if you would have graphed it, the function of the graph would have looked like that. And we're looking at from -1 to -2, and we're looking at this region. Area of this region is below the x-axis, so it's going to be negative. That's why we got negative. All right, here's a tricky one. 2 of this x squared of dx. Well, if you use the fundamental theorem of calculus, you know that whatever it is, you're subtracting by itself, so therefore it's going to be 0. Okay? Antiderivative x to the third over 3 minus x to the third over 3, and both values are the same, so therefore it's going to be the same. So let's try this one. We're going to have our exam next week, and then we're going to have our final exam following Monday. So you will have the result by Tuesday. Here's one of the properties that one can use to make your life easier. Remember I said the smaller number is in the bottom and the bigger is top, but what if the problem was given like this? Can you change it? Yes, you could change the top and the bottom, but you could just have to put negative in there. All right, let's find the antiderivative of it. I'll wait a bit. Just give me the answer for it. I'll give you a couple minutes. All right, so if you look at the antiderivative of that, you will get oh, sorry. What am I doing? I made it 2x, sorry. This would be x to the third. Okay. So now, if I look at the antiderivative of it, x minus x to the 3 over 3. And we're looking at it from 2 to 4. And if I plug that into the function, let me make sure I did that. 2x, x cubed, yep. So 4 minus. We get our answer to be negative 50 over 3. Oh, and then we got to plug that negative in here, and it becomes positive. Okay. So far, these are easy problem. All right, let's look at this one. This is a bit tricky one. Try this. Okay, so if you look at it, what's the answer did you guys get? I bet you got 0. Here's the reason why. If you would have graphed it, your graph from 0 to 1 would have kind of looked like that. And we want to find the area of these two regions. And both of these two areas will equal to each other. So whatever you get on this side will be the negative of that side. So it cancels out and you get negative. I mean, that's why you get 0. All right, so on the test, you're going to get a question like this. Find the area of the shaded region whose equation is y equal negative x squared plus 3x. So just to give you a hint, graph it. And then find the x-intercept. Then you can graph it. So if you would have graphed it, this would have looked like upside down parabola. And the 2x-intercept would have been, you just set it equal to 0 and solve for x. And you would have had 0 and 3. So again, you're just finding the volume area, negative x squared plus 3x dx. Just give me the answer in terms of fraction. So let me just go directly to it. You get negative x cubed over 3 plus 3 half. That's the 3 half from the x squared from 0 to 3, and you will get 9 over 2. Let me give you the mean value theorem. The formula goes like that. F of C times B minus A. And in olden days, that's what people did to do the integration. Because they didn't have a lot of tools, this was a little bit easier to do. So what it said that if we looked at a closed interval from A to B, we could find a number C such that inside that interval, that f of c times b minus a will be the definite integral of that functions from a to b. That's all. Now from that, we get second fundamental theorem. We started to understand second fundamental theorem of calculus, and it's not going to be on the test. So assume f is continuous on an open interval I containing a, then for every x in the interval, the following is true. So we're looking at the derivative of antiderivative of the function from a to g of x, which is a continuous function. What would that be? It's super easy. So you just get that original function inside that g of x times g prime of x. That's all. We're not going to see the application of that. So the next part, what we're going to do is integration by substitution. This is the hardest one. Integrate. I can't even spell that. Integration by substitution. This is the hardest one. What I'm gonna do is I'm gonna start a new lecture. So come back to my channel in a moment.